All right, so today we're going to do 3.3 and 4.1, scale factors and similar shapes, ratios within similar parallelograms. So 22, which I think actually is 24, to 26. Okay. All right, let's get through this. 24, I think it's right around here. Okay, so 3.3, we're on page 23. That table is a little bit off. We are on page 23. Today is 11, 14, 19. Okay, so it says draw a rectangle similar to rectangle A that fits the given description. The area of the rectangle, then 2, the area of a new rectangle is 1/4 the area of the rectangle A, and the perimeter of a new rectangle is 3 times the perimeter of rectangle A. So we got to draw 3 rectangles. So we'll call them rectangle 1, 2, and 3. We have some space mapped out for you as well. Okay, so take as much time as you need, 5, maybe 10 minutes to draw this. You should pause the video here and actually do try and get each one of these 3 rectangles. If you get stuck, come back to the video and see what we did. Okay, so you've paused the video and now you're trying out to create one of these rectangles. So what I'm going to do is I'm going to identify each of these sides. First, I'm going to identify the short side, and that short side has a value of 1, 2, 3, 4, and the long side has a value of 1, 2, 3, 4, 5, 6, 7, 8. So this has a value of 8. That's too big. All right, so I need something that's 2.5 times. A scale factor is 2.5 times. So what I'm going to do is I'm going to use this long side, 8 times 2.5, and that's my new long side. I'll have the short side, which is 4 times 2.5. That's my new long side, the short side. This one I know is 10. 8 times 2.5 is, I believe, 20. 16 times 2 plus 4. All right, so I'm going to go 20 spaces across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, there's my long side. And then my short side is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Way to the bottom. And the other side, because it's a rectangle, should be the same. And my long side here is 20. I'm going to mark this here, 20, and this side here as 10. All right. Second rectangle says it wants the area of the new rectangle to be 1/4. Okay, well, if I find the area of rectangle A, that is 8 times 4. 8 times 4, the area is 32. That means if I do 32 and I do 1/4, I divide it into 4 parts, and I get 8. I need a rectangle that only takes up 8 squares and is similar to this one. Okay, well, let's try a couple of rectangles and see what we get. I can do a 1, 1, 2, 3, 4, 5, 6, 7, 8. Now, do these two look similar to each other? Not really. This is an 8 by 1. That doesn't seem to work because this one is the same, the long side is the same, and the short side is divide by 4. That doesn't work. Okay, so let's try something else. Let's try a 1, 2, a side length of 2, and 2 times something will be 8. 1, 2, 3, 4. That something should be 4. That looks pretty good. Let me finish this off just to see before we calculate it. The area here is 8 squares. Let me put the 2 back outside. It's because I got 1, 2, 3, 4, 5, 6, 7, 8. That looks good. Okay, And the amount of change from one to the next is times 1/2, and the amount of change here is times 1/2. Oh, good. These numbers need to be the same in order for them to be similar. Okay. All right. So far, number 1 and number 2 are all done. All right. The perimeter of the new rectangle is 3 times. Okay. Now, the idea here is perimeter. Perimeter is 3 times. Whenever we're talking about perimeter, okay, that is the length around, and length is directly connected to scale factor. So my current perimeter is 8. My current perimeter is 8 plus 4, which is 12, plus another 4, which is 16, plus another 8 makes 24. So I need a perimeter that is 24 times 3. So here's number 3. 24 times 3 equals 72. So I need something that's 72 units long. Okay, now this times 3 here, that is going to represent my scale factor whenever I'm talking about a length. Single variable lengths are our scale factors. So I'm going to do 8 times 3 for my blue. 8 times 3, which is 24, and I'm going to have 4 times 3, which is 12. That's going to be my short side. Okay. Again, this here is going to be represented by this value here, triple the length. That is your scale factor. Okay, your scale factor is times 3. They have to be the same. Okay, so my long side, I know this one over here is 20, so it's going to take up pretty much the entire length. That's an extra 4. So I'm going to start in the same spot, and I'm going to go to the very, very end, because the one above it was 20. 1, 2, 3, 4, so 24. I don't have to count the whole way through. Okay, I do have to count the 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Almost to the bottom. That's 12 also. 12, 12. And this one is 24, and this one is also 24. So if you add all these up, 24 plus 24 plus 12 plus 12, we should get 76, which is triple the original. Okay, so I'm going to put a note down here, important note. If we're talking about perimeter or any sort of length, that is equal to scale factor. Scale factor is strictly talking about length. Actually, let me write that out. Scale factor. Okay, if we're talking about area, okay, it's a little bit different. Area, we're talking about still the scale factor, but we have to multiply that scale factor by itself. Scale factor squared. All right, let's move on to question B. It says rectangles A, B, C, D, E, and E, F, G, H are similar. Notation is here. This is what the geometric notation is. This means similar. It's saying that A, B, C, D is similar to E, F, G, H. Okay. Now, it's also important to know that these points should match up. A should correspond to E. B should match up to F. G and C match. And H and D match. Okay. So H and D should match. A and E should match. and F and B match, and G and C should match. So what you'll notice is it's actually shape A, B, C, D rotates before it gets bigger, or it gets bigger and then it rotates. Okay, so we have to match up the correct sides together. So please don't get confused which side is which. Okay, so, oh, here's our hint. Hint, identify corresponding sides before you find the missing side lengths. Shorter side to shorter side, longer side to longer side. So I identified the corresponding angles, and we're going to match them up. Okay, so here's our long side. Oh, we don't know the long side. We know the short side. Short side should match the short side. What you'll notice is I go, this is also, I did blue and red, and here's blue and red. But because they're rectangles, they match the same on opposite sides. Okay, and the reason I did DC instead of AB is because DC has that numerical value there. So it gets from big to small. Okay, this is my pre-image, and this is my image. Okay, all right, so we got a good start here. Take a break, figure out how to solve it given the information we have. 5 minutes or so. Pause the video. Once you've given it a try, come on back. All right, you've either figured it out and you're trying to double check to make sure you got it correct, or you got stuck and you're trying to see what you get. All right, so remember your scale factor. Scale factor is equal to image over pre-image. Okay. Now, the information that we have here is our image, which goes here. And the only one that we know is this one. So I'm going to put that 3 there. Okay. We also know, what color should we use? We'll use brown because we don't use it very much. Over pre-image. Okay. And our pre-image value is this one over here on the big one. We go from big to small. So that number is 6.75. That is our scale factor. So we're going to use that same information for the big shape. Let's use a dark green instead. I'm now going to go from the 9 side length to the unknown side length. Okay. 9 times scale factor. Okay, that's our scale factor. The same scale factor we used earlier should equal our question mark. Okay. Now, the scale factor we're going to use is the one that we worked hard to figure out. That goes there. So 9 times 3 over 6.75. Okay. Now, some of you might be wondering, how do you solve for that? And it's not as difficult as it might look. Okay. This is what we're going to type directly into your calculator. 9 times 3, that's this part, and then divide by 6.75. So I use calculators with fractions, okay? I don't know what that is on the top of my head, so let's put this in here. 9 adds. Oh, silly adds. 9 times 3 divided by 6.75, and we get 4. So this side length ends up being 4. Okay, so our unknown value, our question mark, equals 4. Good. All right, let's move on. A lot of these things you should be giving a try on your own. So I'll do the same thing with question C. Give it a try first. Identify corresponding angles and corresponding sides. Okay, super important. Identify corresponding sides and angles before you get started. Okay, color coordinate if you need to, mark them appropriately if that's helpful. Whatever it might be, make sure that you identify the corresponding sides and angles first. Okay. All right, give number 3, letter C a try. If you haven't done so yet, if you haven't done so, pause it, give it a shot, and we'll go over it together. All right, so triangles ABC and DEF are similar. Okay, so find the missing side lengths. Find the missing side lengths and angle measures. All right, now, again, let's match these up. A and D match. A and D. Then we've got B and E, so B and E should match, and C and F should match. Now, I've already got all the angles. Angles don't change in similar figures. Angles or shape stays the same. Okay, so that means this one and this one match because of the way they're written and the order they are written in. This one is, oh, we don't know that one. We know they're the same, so we can figure that one out. Okay, so let's do that one first because that's a little bit of a review. We know a triangle has 180 degrees, and we used up 56, which takes us 130, 124. And then we used up 94 degrees, 0, 12 minus 9 is 3, 30 degrees. So this one should be 30 degrees. So B and E are the same, and F matches C, which is 94 degrees. All right, the missing side lengths. So what you'll notice is we know all of these. This whole one is our unknown. That means that this one is our pre-image, and this one is our image. Okay, so going from one to the next, I'm going to use anything I know both data for. I know this one and I know this one. They are corresponding sides, red to green, red to green. Okay, so here's my scale factor. Scale factor is equal to pre-image over image. And our pre-image here has a known value of 6, and this one has an unknown value of 7.5. Oops, I got it backwards. Got that whole thing backwards. So let's fix that. This one should be image over pre-image. Okay, this one is 7.5 over 6. Now, the reason why I knew that right away that I made a mistake was because I know that my shape is getting larger. Okay, it goes from a small shape to a big shape. If that happens, then I know my number needs to be bigger than 1. When I had 6 over 7.5, I knew I made a mistake. Okay, important to have your notes and to double check your work. Okay, so this is the scale factor I'm going to use. All right, so I'm going to use unknown value to an unknown value. So let's do this one first. 3 to question mark. 3 times our scale factor, And our scale factor is 7.5 over 6, and that'll be our first unknown. Okay, and I'm going to take the calculator just one time out, so I'm going to do the same thing. I'm going to set up the next one. 5 to the question mark. 5 times the same scale factor, because we're using the same two shapes, 7.5 over 6, and that's going to equal our second question mark. Okay, so here's our calculator. We'll just type that in. We've got 3 times 7.5 divided by 6, and we get 3.75. So this new side length is 3.75. And same thing here. We'll set up the equation 5 times 7.5 divided by 6. And you can see all of it on the calculator screen right there. 6.25. 6.25. All right, so this one is 6.25, and this one is 3.75. Oops, got that backwards. 3.75 is the red one. 3.75. Okay, nested triangles. Same thing with D and E. I'm going to go through these fairly quickly because the video is getting a little long. But what you do is try them, check your work, try them, check your work. Again, you need to try them. You should not be finishing before the end of the video. However long the video is, your work should be a little bit longer. Okay, so again, I'm going to move this down because this is important to know. Okay, you should always find corresponding sides and angles. Nested triangles are a little bit trickier. Okay, there are two triangles here. There's this triangle, and I'm going to trace it because I can. Okay, that's one triangle, and we know the side lengths of those are B, D, and E. Okay, there's our first triangle. I forgot part of it. All right, there's our first triangle, and here's our second triangle. Okay. Our second triangle is ABC. Triangle ABC. So that means that the ones that match are going to be B and B are equal, of course. E and C are equal. And I already did blue. D and A are equal. Okay. Now, my recommendation is nested triangles. One is inside the other, is to make sure that you draw them separately. It's easier to see them in separate spaces. Okay. So it says sketch and label two triangles that you see, identify corresponding angles. So let's identify those. We know that angle B corresponds to angle B, which we just did. We know that angle A corresponds to angle D. Both of those are brown. And in green, we know that E and C match. Angle E corresponds to angle C. Okay. All right, let's keep going. We're going to see the two nested triangles. This is a very difficult question to do on your own. Give it a try, identify your two triangles, and label them. Okay, label them. If you don't label them, it's going to be a lot harder. Okay, again, you should be pausing this video for about 10 minutes and getting through this work. All right, so identify the nested triangles and label the sketches. Okay, so this one is going to be, I'm going to label these all in the same color. This is the tree 2, that's over here. This is tree 1, that's over here. This one is stake 3. Okay, now this one is also stake 3. And this one is stake 1. Stake 1, and this one is stake 2. Okay, now when they're asking you to label them, it's important to note that they're also asking about the distances. We know this is 120 feet from here to here. Okay, this one is an unknown. We don't know what that is. We also know that this one here is 80 feet from here to here. And this one is 140 feet. Okay, now the nice thing about that is we now have two corresponding sides that we can find the values of. This side and this side correspond to each other, and we are going from small to big. Okay. All right, so what is the distance across the river from stake 1 to stake 2? Oh, to tree 1. Explain your reasoning. So we got to figure this out. We got two triangles, and we go from 80 to 140, so we got to identify our scale factor first. This one is our pre-image because we know both of the values. This is our image because we have an unknown value. So our scale factor is going to be image over pre-image, 140 over 80. If we reduce all those by 20, we get 7 over 4. Divide that by 20, that's 70, or 7. Divide that by 20, we get 4. Okay, scale factor, well, that's very important to know. Okay, now we got to do the same thing with the 120 to the question mark. So, and this is our image, I forgot to label it. We got 120 times your scale factor times 7 over 4, and that should equal our new value of this distance. Now keep in mind, that's the entire distance, okay? That's the entire distance. So I'm going to type this into the calculator, but this time I'm going to do it on my phone, just so we don't have it. Actually, no, it's okay. Put it back here. 120 times 7 divided by 4, we get 210. So this distance here is 210. Okay, now if this is 210, that is not the distance from, that's the distance from stake 3 to the tree. Now when we read the question, it says stake 1 to the tree. It wants to know this distance from here to here. Okay, we know the entire red distance is 210. How do we figure out the river or the stake to the tree? We have to take this part away, minus 120, okay? Because we're not asking about the stake 3 to stake 1. We know that this one should equal 90 feet, okay? So 210 minus 120 equals 90 feet, okay? Now that is not an explanation. To explain that, we need to find, because stake 3 to tree 1 is 210 feet. Sorry, that's my morning alarm. Is 210 feet, and we need to take away or subtract, take away the distance from stake 3 to stake 1. Okay, describe the relationship of the perimeter of the smaller triangle to the larger triangle. Remember, perimeter is directly related to the scale factor. Perimeter is the same as scale factor. Okay, you're going to do F on your own, just like we did the other one. Okay, should be completed. I'm not going to post it on this video. Okay, your second